Zero and negative exponents. Zero as an exponent. For any number except for 0 raised to the 0 power, the answer is always going to be 1. If 0 is raised to the 0 power, the answer would be 0, because 0 raised to any power will always be 0. But when you have any number other than 0, and it's raised to the 0 power, the answer will be 1. Let's take a second to think about that. We know that we subtract exponents when we are dividing two powers with the same base. So if we had 5 squared divided by 5 squared, we would leave 5 alone and subtract the exponents because we're dividing. 2 minus 2 is 0. So 5 squared divided by 5 squared is equal to 5 to the 0 power. But let's look at 5 squared divided by 5 squared. That would mean 5 times 5 divided by 5 times 5. Well, 5 times 5 is 25, so you would have 25 divided by 25. And anything divided by itself is equal to 1. So 5 to the 0 power is 1. And this is going to be true with any base that you use. So no matter what the base is, as long as it's anything other than 0, your base raised to the 0 power will always be 1. So if we have 1,000 to the 0 power, the answer is 1. If we have 3 to the 0 power, the answer is 1. If we have negative 17 in parentheses to the 0 power, the answer is 1. 1 to the 0 power is 1. 90 to the 0 power is 1. Even variables, m to the 0 power is 1. W to the 0 power, I know this is annoying, but it's proving that anything to the 0 power is 1. Now, your negatives do need to be in parentheses. If your negative is not in parentheses, then it would actually be a negative 1. Now let's talk about negative exponents. For any non-zero number a, where a is the base, your base raised to a negative exponent is going to be equal to 1 over the power with a positive exponent. So for any non-zero number a to the negative n power is equal to 1 over a to the positive n. Again, let's take a second to think about it. We know that we subtract exponents when we are dividing two powers with the same base. So in this case, I have 5 squared divided by 5 to the 4th. We're always going to subtract the top exponent minus the bottom exponent. In this case, I would have 2 minus 4, which is a negative 2. But let's look at 5 squared divided by 5 to the 4th really quickly. Remember, 5 squared is the same as 5 times 5, and 5 to the 4th is the same as 5 times 5 times 5 times 5. Remember, when we have the same thing on both top and bottom, we can go ahead and cancel out. 5 divided by 5 is 1. 5 divided by 5 again is 1. But this time I'm left with 2 5s in the denominator. They're on the bottom. The numerator is going to become 1 because 5 divided by 5 is 1 and 5 divided by 5 again is 1. So this is equal to 1 over 5 times 5. Well, 5 times 5 can be written as 5 squared, so it would be written as 1 over 5 squared. So 5 to the negative second power is equal to 5 squared. When we're talking about exponents, generally speaking, unless it does not ask you to, but generally speaking, you're going to want to use positive exponents in your answer. So if you were to get something like 5 to the negative second power, you would want to rewrite it as 1 over 5 to the positive second power. This asks us to simplify each expression. If you look at 3 to the negative first power, I can rewrite that as 1 over 3, And remember, there would be an understood exponent of 1 on the 3. It's not necessary to write it in, though. W to the negative fourth can be rewritten as 1 over W to the positive fourth. And 6 to the negative second can be rewritten as 1 over 6 squared. Because the directions do not necessarily ask me to keep it with a positive exponent, I need to go ahead and multiply. 1 over 6 squared is the same as 1 over 6 times 6, which is 36. So 1 over 6 squared is the same as 1 over 36. This asks us to simplify each expression expressed using positive exponents. So my answer should only have positive exponents in it. 4 to the negative second times 4 to the negative third. This is going to go back to using my power rules with multiplying and dividing two powers with the same base. In this case, I'm multiplying two powers with a base of 4. So I need to go ahead and add the exponents, which would be 4 to the negative second plus negative 3. Negative 2 plus negative 3 is negative 5, so I could write it as 4 to the negative fifth. But it asked me to express using positive exponents, so to write 4 to the negative fifth using a positive exponent, I'm going to write it as 1 over 4 to the positive fifth. The next example, we have r to the negative third times r to the fifth. This is going to be r to the negative 3 plus 5. Negative 3 plus 5 is a positive 2, so it's r to the squared, or r to the second power. And finally, I have h to the negative second divided by h to the fourth. Remember, when I'm dividing two powers with the same base, I subtract the exponents. The exponent in the numerator, or on top, minus the exponent on the bottom, or in the denominator. So this would be h to the negative second minus 4. Negative 2 minus 4 is negative 6, so I have h to the negative sixth power. I need to write that using a positive exponent, and I do that by writing it as 1 over h to the positive sixth power.